Welcome to The Explainer. Today, we're diving into something that might just change how you see, well, everything. We're going to explore a new kind of geometry that challenges about 2,500 years of math by asking a really simple question. What if our tools for describing the world were actually built for a curved world from the get-go?
Okay, let's start with a problem you've definitely seen before. You know how when you look at a flat map of the world, Greenland looks absolutely enormous, almost as big as Africa? Yeah, that's a lie. Every flat map has to stretch and squash the globe to make it fit. It's a necessary lie, sure, but it points to a much deeper problem with the very tools we use to measure our world. And this really gets to the heart of it. On one hand, you've got the math we all learned in school, Euclidean geometry. It's all about flat planes and straight lines that go on forever without meeting, perfect for a piece of paper. But our world isn't a flat piece of paper. It's a sphere, where the shortest path is a curve and parallel lines eventually meet. The math we've been using just doesn't line up with reality. So what if we just stopped trying to force a round peg into a square hole? What if we built a whole new geometry from the ground up, one that actually embraces curvature as its starting point, instead of treating it like a problem? Well, that's exactly the idea behind Spherion.
And I want to be super clear here. This is not just some minor update. The folks behind this are saying it's a complete paradigm shift. It's a fundamental challenge to the way we've thought about space since the ancient Greeks. We're talking about a total rethink of how we describe location itself.
So how in the world does it work? Well, forget latitude and longitude for a second. Think of it more like a file path on your computer. The whole Earth is your C drive. You divide it into, say, 6 big folders, and you pick the one you're in. That's the first number in your address. Then you open that folder, and it's divided into more subfolders. You pick one of those, and you just keep going. Your location becomes a path, a series of choices that gets more and more precise.
All right, so let's get into the nuts and bolts of how this system really builds a more intuitive and, frankly, more powerful way to handle location, especially when things get messy and uncertain.
Creating a Spherion address is just this beautifully simple repeating process. You start with the whole sphere. You divide it up, you pick the zone you're in, and then you just do it again. Each step down that rabbit hole adds another number to your address and sharpens your location.
Now here's where it gets really cool. That address, that string of numbers, isn't just a random label. It's a story. It's the entire history of that location, from its general neighborhood on the globe all the way down to the finest detail. The whole lineage is baked right into the address itself.
This totally flips how we think about data. With old-school coordinates, you're dealing with an infinitely precise point, and any uncertainty is just an error, right? Something to get rid of. But in Spherion, the basic unit is a whole zone, an area. Uncertainty isn't an error, it's a feature. Your location can be spread across a few different zones, which is, a lot closer to how a real sensor actually sees the world.
Okay, you might want to buckle up, because this is where things get seriously mind-bending. See, once you change the fundamental rules of space, you suddenly have to rethink everything else. Concepts like time, truth, and even what causes what. So forget the idea of a single timeline for the whole universe just ticking forward. In the world of Spherion, time sort of emerges from the structure. Progress isn't measured in seconds, it's measured in detail. As a system gets more defined, as its address gets longer, it kind of becomes more. Time is about how deep you are, not how long it's been. And that shift has some really profound philosophical consequences. An event isn't a point in space-time, it's a change in the structure. And truth isn't just a simple yes or no. For instance, saying I'm in Paris might be true at a broad city-level resolution. But if I zoom in and I'm technically in a suburb just outside the city line, that truth actually changes. It depends on your level of detail.
Okay, I know what you might be thinking. This is all fascinating. But what can you actually do with it? Let's bring this whole thing back down to Earth and look at some real-world applications.
You could literally build a new kind of computer from the ground up. A Spherion operating system wouldn't think in terms of flat files and linear logic. You could have a truly spherical 3D user interface, finally getting rid of the whole desktop idea that's been with us for decades.
And the potential uses are just huge. We're talking robotics, quantum computing, climate modeling that can focus its resolution right on top of a storm, spatial databases, even augmented reality, creating digital objects that are perfectly locked into the real world.
But here's the real kicker. On top of all this elegant theory, it's also ridiculously, radically fast.
Because locations share a common prefix in their addresses, finding everything inside a big area is as simple as a text search. It's incredibly efficient.
How efficient? How about 40 times? That's not a typo. For spatial databases, Spherion can create indexes that are up to 40 times smaller than the traditional ways of doing it, for the exact same precision. That's an absolute game changer.
Just think about a robot for a second. Right now, it's a mess. It's got data from cameras, lasers, motion sensors, all in different formats that have to be painfully converted and stitched together. With Spherion, it's like every sensor suddenly speaks the same language. Fusing their data becomes simple, fast, and way more reliable.
At the end of the day, what Spherion shows us is bigger than just a new coordinate system. It's proof that even our most basic, long-held ideas about the world aren't set in stone. It forces us to ask a really big question. If the geometry we've all been using for over 2,000 years was really just a good enough approximation for a flat world, what other fundamental ideas are just waiting to be reinvented? What else have we been taking for granted?